So that being said, now since Palo Alto is a software-based firewall, okay, software-based firewalls, I think I have explained my term why I use the word software-based is because the core structure design of the firewall is a software-based engines. That's why I use this term. So here, the way it handles the packet is also something which is uh, quite a little complex, I would say, but the basics would remain same as what is for any other firewalls. Okay, so that being said, let's start. So see what happens is when the firewall receives a packet on its interface, okay, the first thing what it will do is integrity check, the EOP operations. That's what it is going to do. Okay, so here the firewall will check whether the packet is properly structured as per the RFC standard or not. Like the packet must not have the source IP and destination IP as the same, right? The variables of the packet headers, that is IP header, TCP header, ETH header, whatever that the packet is carrying, is or must have the RFC standards definition, right? So it should not contain the values or variables which is not as per the RFC. So all these things will be taken into account, right? It will also check the integrity of the packet, meaning that whether the packet I have received has not been modified in any other way, right? So how it will do that? Based upon the checksum values of the headers. The IP header has the checksum value. TCP header has its own checksum value. ETH has its CRC checksum values, right? Every header has its checksum values. What is the use of that? It confirms the integrity that that header has not been modified. The content inside that header has not been modified. Think of that as a seal on a bottle. If that seal is broken, we know that we have a doubt that if that the bottle seal is broken, that means the content inside that bottle might be compromised, right? But if the seal is intact, we know that whatever that the bottle carries is safe, right? So that's the whole point of having the checksum in the header field. Now, after that, what happens? After that, it will, if in case it's a fragment packet, then it will try to reassemble that fragments. Okay, if it's a encrypted packet of an VPN or something kind of a thing, then it will try to decode it. Okay, so all those things I'm adding in the part of integrity itself, because that's where the integrity will be checked. Once the packet has been arranged, then it will check the integrity. If the packet is encrypted, then it will decode it, and then it will check for that same thing what I've just mentioned. Okay, so after that, then it will see, does it have a session? Okay, so session match will happen. Okay, so first thing, integrity check that we talked about. Now after that, what it will do is it will go for session match, that the received packet, is it matching with any of the session? If yes, then it knows what to do, right? Then it will move to the fast path. Fast path means directly jump to the conclusion how to send the packet out, and while natting which policies and all that, that's where it will come into play. But if there is no session match found for the received packet, then it will check.
Rohan, sorry, just to break. So, could you please explain session once again? I mean, in a layman language, like what actually happens?
Okay, see, session is uh, nodes of CPU. मेरा क्रॉस बैग में देखो उधर. Okay, see, session is nothing but the nodes of the main CPU. Okay, so when the CPU processes your traffic now, it keeps on writing the notes that, okay, this packet has matched against this policy. As per this policy, we have to change the source IP to this IP, source port to this port. As per the DNAT match, we have to do this translation. So whatever the main CPU did with the first packet, that is the life of packet, which I'm explaining you right now, the outcome of that is session. So this entire extensive process is only done once, not for every traffic, sorry, not for every packet belonging to the same session, but only for the first packet of that specific session. Okay. Once that entire process is done by the CPU, he will make a note of it, that what did he do? And that note is called session. Okay. Clear? It's a handwritten.
Yes, yes.
And
Okay,
this will make
okay.
more sense once I explain you the entire process, and then I will tell you what I mean when I say that if a traffic is matching with the session, then it will skip a certain step and it will stately take that action. Okay. Rather than starting from the scratch. So let me just complete with the flow and then I will come to that session point, that what actually the session carries and why.
Sure.
Okay. Now, see here. So like I was saying that it will first check that that whether this packet what I've got, is it matching with the existing session? So there are two things here. First thing, how is the firewall checking that this packet is matching with the session or not? How does it check that? Okay. So I will explain these same pointers thoroughly when I will be touching the troubleshooting points and all. Just for now, I'm giving you a layman. It checks for incoming, that is your source interface, destination interface, source address, destination address, source port, destination port, your protocol number. Okay, so these are the 6 tuples, I think 2, 2, 4, 5, 6, 7 tuples, which has been used in order to match against a session. Okay. Okay. So if a traffic has been matching with all these 7 parameters, then only it will say that I'm matching with an existing session. Now, maybe this is not making sense right now, but as I'm saying, this is only to give you a common sense of view that what is the firewall doing. Each and everything we will be talking about in depth later on. Okay. Now, so let's say there is no session match. Then it will try to check. Does the received packet represents the first packet? If yes, then it will try to create the session. What do I mean by that? See, let's say there is a first packet which came with SA flag and it's a TCP packet, protocol number 6. Okay, TCP. Now, do you think that the TCP first packet will be the packet which contains SYN and ACK flag? No, no. TCP always shares SYN, SYN, ACK, right? Right, na? The first packet will only have SYN flag, na? It cannot be a SYN, ACK, right? So this is what is being checked. If it's the first packet, then it will allocate a session number to this traffic. And then it will start processing it. Then it will start processing it. How? See. Now, when it will start processing, it will first try to check whether I have got the proper policy match or not. Okay. It will check all these um, policies lookup. Here, the word policy does not seems as right as it seems to, but let me use the word zone here because you might see zone match, zone lookup, something like that. So here I'm talking about security policies. in terms of zone application. Keep in mind, in Palo, you cannot define the policy based upon source interface and destination interface. Rather, it is based upon the zone basis. Okay. So zone is also something which you can think as group of the interfaces. So group of the interface is a zone. Okay. So zone is also equal to interface. Okay, so you can say policy lookup, or you can say security policy applications. So those will come into play. Now, can the policy be done before routing? Is it possible? Is it possible? Because the condition says that traffic is set to be matching with the policy only when if the source interface, destination interface, source address, destination address, your destination port and protocol number, these are matched, then it's a policy match. Now I have two questions. Please respond to that so that I know about my audience here, how depth I have to go. Why is source port not part of the policy match condition?
Because all the packets which is coming via the source
That
port
is
uses the
random.
WAN.
Yes, that is random. You have 0 to 65535 range,
Mhm.
out of which 0 to 1023 and 1024 to 65535, right? These are source port range. In simple words, random ports. Whereas this is destination port range, meaning well-known ports. This is what the concept is, na? Port
Right.
number of SSH 22. Port number 443 HTTPS, port number 80 HTTP, port number 179 BGP, right? Port number 25 SMTP. All these ports, what I've just said, is are well-known ports. We know what these ports are there to do. But whereas if I say port number 8982, now I'm not sure what this 8982 will do, right? Because it's a random port. It can be used for anything. So when the browser is trying to send a traffic to the Google, I know what is the destination port it will be putting in the packet. That is 443. But I have no idea what will be the source port used by your browser. So something which is random and has no pattern into it, I can't have a matching condition defined on that parameter. That makes sense, right? Correct? Second, SEER. Matching condition is destination interface. So when a firewall receives a packet, it does destination, it needs a destination interface to match against the policy that has been configured. What is the process or function which will tell the firewall that, hey, this traffic needs to be sent out from where? That is route. Route lookup? Yes or no?
Yes.
So route lookup will be done in order to identify what is the outgoing interface always. I'm giving you a layman in here in terms to integrate this concept with reference to any other firewall, any other product that you work with. Routing will always happen before the policy. Keep that in mind. Always. Never ever you will see that routing has happened after the policy. Okay.
Hello.
Yes, please.
Yeah, we already do the routing in router, right? What it is on the
Brother,
firewall.
your audio is like it's like it's very, very slow. It's really hard for me to hear you.
Okay. Uh, we already do routing in the router, right? Actually,
I'm not sure. Is it only with me or it's with everyone?
You can't hear him.
It is for everyone. I'm also not able to.
We also not able to hear, sir.
Okay, because I'm struggling hard to hear him. If you have questions, brother, you can please type it in the chat. Can you do that? Okay. Now, okay. So now see here, what happens is it will do the route lookup in order to identify the destination IP. And then it will try to match against the policy, that do I have the policy in order to do what I'm supposed to do. Okay, whether I have to allow it, I have to deny it. That is whatever configuration that you might have configured. Okay. Now in Palo, the after the policy, okay, or I would put it in this way. Let me also give you a gist in here. Okay. This routing lookup that has been done here is actually the route lookup, which is the okay, let me put in a different manner. Dekho, like this. There are two types of route lookup. Okay, let's get clear with this, and then I will explain you what do I mean by that. So there are two different route lookups. When you get a packet, you have source IP and you have destination IP in a packet, right? Now keep in mind, route lookup that is done for the destination IP is called forward lookup. Most of you would be knowing this. I'm just giving you the clarity of the terms. Route lookup that is done for the source IP is called reverse lookup. And we know why. Because when a packet has been sent, let's say with the source 192.10 and destination 8.8, and if the reply would be coming, the reply would carry this, that the destination would be now in the source and the source would be now in the destination, right? So for the reply traffic, the routing lookup will be done for 192.10 to know that how to send the reply back. Correct? Right now, that is, we are calling
Yes.
it reverse lookup. Make sense? See, previously what used to happen now, that when the reply traffic would be there, then the routing lookup would have happened for the reply packet. But now that's not the case. Now, every device is a stateful device. A stateful device means you only have to configure the traffic for original direction. That is direction of the first packet. You do not have to configure your firewall to deal with the reply traffic. You don't have to. Because when the firewall processes the first packet itself, it automatically creates the entry for the reply also. That how the reply will look like. And if in case a packet which is matching with this pattern, then how that reply would be handled. Everything will be maintained in the session entry by the CPU. He will do it. He knows how the reply packet will look like. And he knows how to deal with it. Why? Because it is not only doing the forward lookup, but he's also going to do the reverse lookup. And reverse lookup is not only done in order to maintain the stateful entry, but also it helps you to prevent from the spoof attack, which every firewall does it. Everyone. To prevent from the spoof attack. How? Dekho. See, this is a router. It has three interfaces. Let's say port 1, port 2, port 3, and there is a routing table. And we are saying that as per the static entry, network 192.168.1.0/24 is reachable via port 1. The other entry is saying 172.16.1.0/24 is reachable via port 2. Okay. And the other entry is saying that 0.0.0.0 default route is reachable via port 3. Now what happens is on the port 1, I'm getting a traffic saying 172.16.1.0 1.10 who wants to go to 8.8.8.8. This is the packet what I'm getting. Okay. Now, if I will do the reverse lookup for the source IP, as per that, where is 172.16.1.10? How I can reach that? How I
Via
can
port 2.
via
Via
port 2
port
because
2.
it will match with the route
Via port
which says that this network is behind the port 2.
Yeah.
/20.
Meaning, if this network is behind the port 2, then how come I am getting the traffic from that IP on the port 1? Is it possible?
No.
No. That means someone is trying to spoof the packet. That is called a spoof attack scenario. Clear? Okay, so
Yes.
reverse lookup is not only done to maintain the stateful entries, but also it helps you to ensure that the spoof attack does not happen.
It is
Clear?
a one type of issue. It is
Sorry, it is?
like when coming to live, it is a type of it is a like one type of issue. It is
It is
Huh.
spoof
not an issue.
It is
It
not an
is
issue.
an attack. It is an
attack.
attack.
Yeah. Yeah. Okay.
Okay. Now, see here. So, see why I have mentioned this now because of two reasons. Because in Palo, routing lookup happens twice in Palo. One is before natting, and the other one is after the DNAT check. DNAT means destination network address translation. Here, in some simple words, I'm saying that the firewall will check that if there is any DNAT rule which is matching against the traffic that I have received. If yes, then please change the destination IP or the port number according to it. Okay. And if there's a DNAT match, then it will change the destination IP. And when that happens, then after that, it will again do the routing lookup. Why? To find out the actual outgoing interface that will be used to send this traffic. And then it will match against the policies. Because after all, the policy is matched with reference to the sixth tuple, that is your incoming interface, outgoing interface, and all that, right? That's right. Then the question is why it is doing this routing lookup twice? Of course, to be honest, if you look on some different firewalls, this is not the case. DNAT will happen, and then the route lookup will happen once. But here, why it is doing it? Because Palo Alto gives you zone protection. It also gives you the power to apply the ACL kind of rules at the interface level itself to ensure whether you are going to allow it further or you are going to drop it. That's why it does it. Clear?
Sorry, I missed it. Could you please repeat what you said, the last sentence?
Okay, see, in Paluna, you have a zone level deployment. Okay. In Palo, you have zone label deployment, meaning, like I said, okay, let me show you what do I mean by that.
Is
You
it
will,
like the traditional firewall concept of inside outside DMZ, something like that?
similar to
Or
trust
it's
to untrust
different?
kind of a thing, right? Traditional to that.
Yeah.
Like in Cisco, we used to have it similar to it. Okay.
But sorry to contradict this one, but in the other class of Fortinet, okay, you said that the zone concept does not exist anymore
Here
because
also,
of the
here I stand by that same term. Zone concept does not exist anymore. It doesn't matter. And when I will show you that, I stand with each and every word what I say in the FortiGate also. Nowadays, those days are gone. Trust to one trust, untrust to trust, DMZ and all that. That's for us. For the firewall, it's just interface. Firewall does not give a
yeah,
damn that whether it is coming from trust or it is coming from untrust. He will treat the packet in the same fashion as it would have treated on any other firewall. Sorry,
Well,
any
I
other
agree with your
interface.
statement. Well, I agree with your statement, but if that is the like a current nature of the exploits that are going on, then
Mhm.
why Palo is coming up again with this concepts
See,
of
Palo is
trust?
is not saying that if I give you the zone power, that means I have changed the behavior. Palo is not saying that. Palo is saying that I want you to apply the policies based upon the zones, not based upon the interfaces. And if you remind or if you focus what I taught you on the FortiGate also, that if you hear the word zone, zone means group of interfaces, just like interface, right? So instead of defining the policies here based upon the interfaces, he is saying define the policies based upon the zones. That's what he is saying. Okay. I will show you and this will make more sense to you. Just give a moment. The fundamentals will not change no matter which product you are at. देखो, I will not go in depth, but I will just show you the gist because each one of these things will be explained later on to the classes. Okay, so we will learn each of these things separately. I will directly move to the policies. Come on. Okay, see here, the policy that you have to configure, right? Now, if I click on add, I'm just showing you a policy in here. You see source. Do you see here? It asks you four things: source address, user, in terms of the sources. And you see it is source zone, not the interface. दिख रहा है? It asks you to add what? Zone, not the interface. Meaning, although you have the network interfaces here, if I show you, देखो, here you have these interfaces, ETH1/1/2, 3, and 4. But do you get the option to add these as an policies that incoming interface is ETH1/1, outgoing is 1/2? No. When you configure the interfaces, when you define it, it asks you to map your interface to a certain zone. You see this? Like I have mapped it to LAN. Okay, मैंने इसको LAN से map किया है, ETH1/1 को. And so does I have mapped 1/2 with the zone called internet. That's me. Whatever I want to call it, I can call it. Why? Because when I will configure the policy, you will see I have configured the policy saying that traffic coming from LAN zone, right? Source LAN, destination internet. Clear?
But Rohan, one thing, like, let's suppose I have multiple interfaces, which I do not want as a LAN. Then what happens? Like that, I mean, when I'm adding this rule, so this policy is getting applied to all the interfaces, but I want to bind them in on a single interface. Then it is not complicating. I mean, just
Of
asking.
course, it is. It is.
Okay.
And that's how the Palo is designed. Your question is absolutely right. Let's say I have mapped port one, oh sorry, ETH1/1, 1/2, 1/3 as the zone LAN, right? Now, if I apply this rule, sources, what the policy, what you are seeing in here, it is applicable for all those interfaces, right? That's true.
But here
Uh,
we are defining the address also, right? So
That's
that makes
no,
it
that's
more granular,
huh.
even if it is a
You
zone.
can, you can. But because based upon the source IPs and all that, you will see it with a different point of view. But the point is the same policy applicable for all three interfaces? The answer is yes.
Rohan, we can create more zone, right?
And not
Because if
only, yes, yes, you can create multiple zones, as many as you want. There is no problem with that. Okay?
okay.
And not only that, you can add multiple addresses also, right? So if you are
So
having
maybe
multiple interfaces, face is there,
So
and you want to add the subnets also belonging to each and every interface, that is also you can do. But as far as to achieve the independence from the zone deployment, that only I want to configure a policy which matches with this specific interface, but not with all the interfaces which are part of this zone, that is something which is not doable in the Palo Alto. Okay. Yes, please. Someone was saying something.
So how many zones we have? Like I mean, if I see, let's suppose I have some specific rules for interfaces. So then I need to tag every single interface as a different zone. Can I do that,
You
or it's not
can.
possible? I
It is
can, right?
possible. You can.
Okay, 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 okay.
If you have 10 interfaces and you want to have each interface assigned to a different 10 zones, you can.
Mm-hmm. Mm-hmm.
No one is
Okay,
going to,
that privilege is
that is a
there, right?
problem.
Like, okay, okay,
Yes.
okay. I thought in.
Yeah,
Okay,
that's how I
okay.
have done it. That's how I have
Ah,
configured and assigned the interfaces to respective zones. See, I can click in here and I can say that which
mhm.
zone, new zone, and then you can just write the zone, whatever. Like I'm saying test zone, right? That's okay. So I
Okay,
have got a
okay,
zone called test.
okay.
Okay, so
Then
it's
it's
up to you
possible.
what you
Like,
want.
yeah, yeah. Okay, okay, okay.
Clear?
That makes sense. Yeah, thanks.
Okay. Now, so like I was saying that, see, here in Palo, you will see that the routing lookup happens twice, especially if in case it has matched against the DNAT. Then only this condition is true. If it is not matched with the DNAT, then this routing itself will point to the policy. Clear? The second routing lookup is to find out the actual outgoing interface for the NATed IP. Clear? Clear?
Yeah.
Yes.
Okay. Now, see, after this security policy lookup, it's like the policies matches and all. Okay. Now the firewall is ready to allocate a session. It's like the session has been, because this is all the process to create the session. Okay. So now after the policy has been matched, and here only it will do the ASNAT match also. Okay. So ASNAT and DNAT is being checked at the same time because it's the SP3 model. So it will do all the things at the same. Okay. Applying the security measures onto it also. Okay. So all these things will be done in here, but the session allocation is completed here itself. Here only the session is being allocated as per the Palo behavior. But after this, yet it is supposed to process the traffic with reference to two more functions, that is security enforcement and the authentication, right? So these, your application ID lookup, your content ID inspections, yeah, right, your authentication related checks, all these things will be happening afterwards, after the policy. Okay, that's where it will go into play. Meaning the next content what it will enter is the content inspection here. Where, and if someone is here from the FortiGate classes, then think it as an NGFW UOTM feature actions. Okay. So content inspection here is done in order to identify that whether the traffic is being clean, or is it some kind of threat, some malware, some viruses, or as per what you have configured to apply the security measures, rules of the DLPs, web filtering, application controls, all those things will come into account into the content inspection flow. Clear? Okay. Now, there is one more thing. Since this is a software-based firewall, as I said, that it will be a little complex as compared to the other NGFW firewalls. Now, The policy, once the policy is matched and all, what happens is there is okay, let me put it in this way. I think this would be more easier. So there is a thing called application ID. Okay. This engine is responsible to do what? It identifies that this traffic belongs to which application. Unlike the other firewall, where based upon the domains, IPs, categorizations, and based upon actually the port numbers and all protocols, the firewalls used to identify that, okay, hey, this is YouTube, this is this. Okay. That's not the case with the Palo. Palo identifies the application independent of these common parameters, because the concept is anyone can act as a YouTube. I can act as a YouTube, which is trying to send the communication on the port 443 and it's a TCP based communication. I can act like that because it's a well-known truth that YouTube functions in this same manner, right? Or I can discard myself as someone else, but I am actually not that person, right? So I can be a proxy or something. So to overcome these or to unmask the actual identity of the traffic, the application ID engine is responsible to identify that. And this is why it is not dependent only upon the scanning of the port, protocol numbers, and these common traffic pattern variables, but it checks the payloads, the entire packet content. And then its engine will try to identify the application. And once it has identified, then it can enforce content. Then it can enforce content. That, okay, hey, now you check as per this measures because I know what this application is. So now whatever security measures you have applied onto this application is now applicable. Okay.
Sir, one doubt, sir. So app
Yes,
ID,
please.
who will create that app ID? So we have to create manually, or Firewall
No,
itself
you
will
will
do it?
not create it. You can, if in case you want to create your own custom application ID, you can. But if you do not, still the Palo can identify, market, and it will tell you that this traffic belongs to a certain application.
Okay, that means for YouTube.com already one app ID is there, already
There,
is defined.
yes, it is there. For everything, it is there. But if in case you want to create your own custom app ID to override something to overcome the applied rules, then you can do it also. Like I will say that the application, let's say I'm saying, uh, there was a case where I was dealing with that. Okay. So let's say now there is a traffic with reference to the SIP. Okay. So what happened is it's like the Palo identified the SIP and it applied the security that is the content security rules according to it. Okay. As per that traffic was getting problem because certain content inside the packet was getting changed and dropped and something. So what we wanted to do is we wanted to treat that traffic in a different manner. So what we did is we defined a custom application, tagged that traffic to it, and then we applied the policy based upon that custom application ID, right? So in that case, the default rules are not applicable to it, rather the custom rules are. So if in case you want to override such a thing, you can do it, or else leave it. The firewall will see it and apply the measures as per whatever you have configured to go with that specific application.
Okay. For why I'm asking, sir, for example, I have our organization, I have internally some application is running. So if I want to manipulating using app ID, so that situation what will do?
So you have what? Application ID mapped.
So I have internally some application is there for one
Uh-huh.
location to another
Uh-huh.
location. For example, I have Germany, or I have to communicate with Germany to India. So internally
Okay.
some application is running.
Uh-huh.
So So that's a firewall doesn't know about that application, right? So which app ID you have to use for this particular application. So that scenario, what we do. For example, for YouTube and Facebook and all already firewall know this is a traffic, and using this app ID we have to filter all things. So internally, if we are using any application, what we do?
See, if it does not know what that application is, then it will by default discard it, right? If it does not know what that traffic is, it will discard it as per the setup rule. So what is the rule that you have set up for the unknown applications?
On
That will decide what it has to do with that internal traffic.
okay, so internal application I want to using for this filter. So that purpose, what we do, sir? So, for example, you said for YouTube and Facebook.
Uh-huh.
That's I understood. So, internal purpose, we have some applications.
So you can
So,
tell her that, okay, hey, if the traffic is having a certain destination IP, certain port, then this must be tagged to the app ID so and so. That's your call. Whatever you want to give it a tag, give
We
it.
can manually add any of the application or any IP related
Yes,
to that.
manually, whatever you want to call it. That's your application, right?
yes. Okay.
Whatever name suits you best to understand that traffic, give that name to it. That, see, you are simply telling the Palo that, hey, if you see a certain traffic which has these values, then treat it as so and so application. Done. Now, whatever policies you have configured there, you would have called that application, right? Whatever you have configured. So those rules will be applicable to that traffic. That's how the application override functions work. Okay, you have the power to
Okay.
go map it to anything that you want to.
Okay.
Okay. And like I said, all these things we will see, we will do, we will discuss thoroughly. This is just a quick glance what the packet is going through. Okay. सब देखेंगे. We will start from the scratch again and we will start doing everything from the start. Now, now let's say the traffic passed the content inspection. Okay. And the content inspection, when I say that means malware checks, threats checks, everything is fine. Okay. So as per your configuration of DLPs, that is the file filters and all that, your application and web filter controls. So based upon your entire UTM features in sort, if the traffic looks good and the content engine is saying, hey, it's all good and all, then it will move to the final stage where it will try to first maintain an entry with reference to the sessions which has happened here only. So whatever changes is needed, it will do that. Okay, in terms of the nattings and all, that entry will be maintained. And furthermore, then it will send it to the egress stage where the packet forwarding will take place. Okay, that will also happen. And hence, based upon the routing lookup, policy matches and all, and if in case the packet needs to be fragmented based upon the MTU check, or the packet needs to be encrypted based upon the VPN or the SSL, whatever the type of protocol negotiation that you are into. Okay, so it will do that, and finally the packet will be sent out with reference to the egress interface. Okay, egress means outgoing. That's what happens. So this is a layman flow in terms to understand this is what the packet is going through overall. But keep in mind, this content inspection has much more in depth, much more in things, what it do there. Okay, this policy has much more in there, what it do there. This application ID has much more sub functions, what it do there. Okay, so those things we will discuss when we will touch each and every topic. As of now, this is what the packet flow is. Clear?
So SNAT will happen after capture inspection, right?
Which one?
SNAT, source NAT.
Source NAT. Source
Yeah.
NAT call is taken at the start only, but that will happen when the packet has been sent out at this stage. Okay. Natting lookup happens before only in like Palo. It knows what to do. But when it will do it, that is at the end, when it will try to send the packet out. Okay, clear? ठीक है?
हाँ सर, यस सर।
Okay, now there is one more thing is, see, the packet at the start, that is at the interface label, could be dropped because of number of reasons. I would want everyone to focus on those reasons, please. That if, like, see, on at every level of the interfaces, it may drop it. Like at L2, a packet will be dropped if in case the destination MAC is not matching with the incoming interface MAC address. I think everyone knows that, right? ये मालूम है ना? Basics. There is a packet coming to the router. Why will the router accept it? Or why will any device accept it? So it's all about the OSI model. Keep that in mind. Layer 1 to layer 7. Whenever someone sends the traffic, the packet is created from layer 7 to layer 1. But whenever someone tries to read the traffic, that means it is layer 1 to layer 7. So your router starts reading from layer 1, layer 2, layer 3. Because your router is a layer 3 device, right? So it will start reading from layer 1 to layer 3. Clear? If you give the power of L7 to the device, that is your firewalls and all, then your firewall can read from layer 1 to layer 7. That's the power of inspection. Okay, next gen power in simple words. But ideally, if we say the word L2 and L3, we are saying that the forwarding decision is based upon L2 or L3 information. That's why we say that switch is a layer 2 device, router is a layer 3 device. That's why we say that, right? What do we mean when we say that, okay, firewall is acting as a layer 3, firewall is acting as a layer 2? Because firewall or router can act as a layer 3 and layer 2 both. What do we mean by that? The word means that the forwarding decision is based upon that, right? How is the device deciding that the packet what I have got will be sent out from where? How? So switch does it by looking in the destination MAC. Router does it by looking in the routing table, that is based upon the destination IP route lookup, right? So that is something which is afterwards. But before, like router is a layer 3 device, so of course it will check layer 2. Why it is checking layer 2? To confirm whether this packet belongs to the device or not. Because the rule says, that means EOP, end operation of the network devices, says that if the destination MAC of the received packet does not match with the incoming interface destination MAC, let's say the destination MAC here is M1 and here is DM, so it is not a match. Hence, the packet will be discarded at the interface level. Clear? And this is the exact reason why you will hear people saying that whenever the layer 3 device forwards the packet, it always modifies the source MAC. Suna hoga tumne, right? It always modify the source MAC. Why? Why does it do that? Because of the same reason what I just told you. Because when the reply will come, think this same source MAC will be here in the destination MAC field, and this destination MAC will be here, right? So if the destination MAC is not matching with the incoming interface, then the router will discard the reply traffic. This is why, to overcome this challenge, whenever the layer 3 device sends the packet out, it always modifies the source MAC address. Clear? Basics clear hai?
Yes, yes, yes.
Okay.
Can I know, sir, why it is going to change MAC address?
I just told you. Okay, let me repeat that. See, the point is now, what I'm saying is there is
See,
a
when the
EOP.
router is keeping same routing table, then why it is switch is going to change MAC address?
It's not the switch, it's the
Uh,
router.
a router, yes, yes.
Yes. So the point is the L3 device, or sorry, let me first talk about the EOP method. Okay, the first point is the device only accepts the packet if the destination MAC of the received packet matches with the ingress, that is incoming interface MAC address. That's the condition. Clear? ये clear है?
But the first,
Sir,
but the
sir,
first
here I
packet,
have.
one question.
Yes, please.
But the first packet, whenever it receives to any device, okay, it
Hmm.
does not know, means whenever any source is sending like a request to the destination, it never knows that what is the MAC. So it is sends to like
That's not
the
true.
like
That's not true. If and thank you for speaking that out. So I know that I have to go in much more depth. Okay, fine. Let me start from the beginning then. Okay, so let's take a step back. Let's address this concern. Simple, okay? Simple. Let's keep it easy. Is this clear? The diagram what I've drawn? Is
Yes,
it
yes,
right?
yes, yes,
Yes, ये सही है ना? The IP standards, everything is fine.
yes, sir.
yeah, fine.
Okay, fine. Let's say, forget about this thing. इसको भूल जाओ. Okay, let's do one thing. Let's put another PC here, PCB. Okay, understand this and we are done with our basics. 1.10/24. Here the IP is 172.16.1.1/24. Okay, tell me if I try to ping from PCA to PCB. Okay, I'm trying to ping from PCA to PCB. What happens? The packet
Mm,
will be created
first,
now.
first it will check
Mm,
whether
yes.
it is in the same network or not,
Huh? So
and
source IP is 192.168. Okay, I
168.
will write in the short form, okay? I will not
Okay.
go in that length. So I will
1.10,
say
1.10.
192.10, destination is 172.10.
1.10.
Then it will try to check the source MAC. Let's say the source MAC of the PCA is MA. Okay, let's say that. This is MA and this is MB, MAC address. Okay. So now it will say that source MAC is your MA. Now what about the destination MAC?
It will be FF
Will be
since you
FF.
don't know. But it don't know, right? It is the first packet, so it
Uh,
needs to broadcast, right?
Okay, could be. Anyone else?
Sir, I have one doubt.
Wait, wait.
So, this PC sends to a request to this router. Actually, router doesn't know this actually destination. This is what my question.
Router does not know
Broadcast
about
IP.
the actual destination.
Broadcast IMAC comes out.
So
Destination MAC could be a router interface MAC address.
No, but how it will know about the router MAC address?
It was the default gateway.
It will
I
create a
think
R packet, sir. Sir, since it is in a
More,
different network, it will first create a R packet for its gateway, that is the router. Then it will send the router and ask for a, like how to get out of this packet or for this network. I mean, first it will create a R packet to for this router and sends like question mark to the router, like I need to get reach out to this particular system. Do you know that something like that?
okay, fine, correct.
Sir,
Okay, so whatever you said, yes.
as per my understanding, whenever a network wants to, like any particular IP wants to reach to the other part, okay, it does an ANDing operation. And during the tanding operation, it tries to find whether it is in the same network or different.
Yes,
And then based upon that operation, okay, it tries to send the packet.
correct.
And since 1.10, that is the PC that knows that, okay, that it has a gateway, okay. So it sends that a packet with the destination MAC, because it does not know, but so it will be like FF. And then once it receives, okay, then I think that the resolution will happen.
Okay,
That is
fine.
my understanding. I don't know whether it's correct or not. I would like your inputs further.
Okay, okay, fine. So see, okay, so let me put it in this way. देखो, there are certain EOP. EOP means end operation, which every network device must perform. They will. And the rules does not change. It remains constant and valid and applicable for every network device. Now, in that EOP, there is one more thing. Okay? देखो. And I think the guys who have been my 40K students before, they know that. See, there also I have told this. If the destination IP is in the different subnet as the source, then the device will look for the gateway IP. Clear? Okay? Keep in mind, if the destination IP is in the same subnet, okay, as the source, then the device will not look for the gateway IP. And this is something which you might have noticed, that if you are trying to ping the system which is within your same LAN, you do not need a gateway, do you?
No,
No,
we
right?
don't need.
You don't need. Okay, so the gateway will only be looked by the device only if the destination IP that you are trying to reach to is in a different network. Then only it will look for the gateway. That's one thing. Next, see, if the destination IP is in a different subnet as the source, then the device will look for the MAC of gateway IP. Clear? Okay. It never looks the MAC address for the actual destination. ये कभी होगा ही नहीं. Never. And to prove that point, let me show you one thing. Let me first remove that to this point. See, to prove that something. See, I am trying to ping A.A.8. A.8 is in a different network as my source IP. If I do the ARP lookup to find out the MAC address, do you see the MAC address for 888? No, right?
No.
Why? Because when I tried to ping now, my machine said, hey, the destination IP is not in the same subnet as my IP, because my IP is something in the 192 series. You can see that. So it's in a different network. So it said, do I have a gateway? It said, yes, I have the gateway. What is that gateway? 192.168.0.1. Okay, fine. What is the MAC for this gateway? See, that's what he's looking. He's not looking for the MAC address of 888. And why is that? Why? Because of the point number one, what I mentioned. See, देखो क्या हुआ. So as per this, currently, the destination IP is in a different subnet. We checked. Do I have a gateway? Let's say the gateway what I have defined is 192.168.1.1. That's the gateway. Okay. So He's saying, yes, I have the gateway. Okay. Then do I have the MAC address for the gateway? So ideally what happens is as soon as you define the gateway, the machine will raise the ARP query for the gateway. Okay. So what would have happened is actually the machine A would have raised a ARP request, that is query, what I'm saying, which is layer 2 broadcast packet, layer 2 broadcast, which says, hey, who has the MAC for 192.168.1.1? Please tell to 1.10. That's what he will say. And when the router receives this, then by default, the condition to reply to a ARP query or request is that the ARP query for which the IP for which the ARP query has been raised must be part of your device. That's the default condition. Okay. But if in case you want to change it, there is one more condition where the router can respond. I will not go into that part. Let's keep on the default behavior. So here when the router will receive it, router will see, okay, hey, you want the MAC address for what? For 192.168.1.1? Let me check. Do I know this guy? Yes. As per my route lookup, this is directly connected to me. It's my port something interface. So he will then respond with its MAC address that, hey, this is my MAC address. And hence he will know what is the MAC address for router, this interface. Let's say it is M1. So he will put M1. Now he's ready with the packet. Now see, now when
Uh,
this packet has been sent, just give me a moment, okay? Now when this packet has been sent to the router, why the router is accepting it? Because the router is doing the EOP. It says that, hey, what is the destination MAC? M1. So it is saying, does the destination MAC of the received packet matches with the incoming interface MAC address? Yes, it does. This is why router will accept the packet and will start processing it. Clear?
Clear.
Okay. So now
But
you know
one
the
question.
EOP messages?
But one question.
Yes, please.
When the PCA is sending the ARP request, okay,
Uh-huh.
ARP packet does contain the information of the source IP, source MAC, target IP, and target MAC. Since we know source IP and source MAC, target IP we know, target MAC is still unknown, and so that's supposed to be like a broadcast MAC, right?
No, no,
Does
no.
my
Why
question is
you
correct?
think that? No, why it will be
I
broadcast?
am
Because
saying
here it is
ARP,
a unicast, huh? ARP. You are talking about ARP or this packet?
ARP,
ARP is the layer to broadcast. ARP is layer to broadcast, brother. See?
but ARP message, okay, ARP packet format, okay, it says that it is a 32-bit and it contains like sender hardware, sender protocol address, target hardware, and target
Yes.
protocol address.
But see the Ethernet. It's a layer 2 broadcast. Layer 2 broadcast means see the destination for the Ethernet. FFFF. That's your
Yeah,
ARP.
that's okay.
That's ARP. Okay. This is the ARP. I'm not talking about ARP. I'm talking about this guy. Now, he raised the ARP. Why? Because he wanted to resolve the MAC address for the gateway. That's why he raised the ARP.
Right.
Once he had it, now
No,
it is a
my
unicast message.
no, my question was like when the ARP like query goes, okay, it contains the like a broadcast MAC address or not?
Yes. Who? Ethernet.
Yeah, Ethernet.
Yes, it will because how he will know the destination?
Right. So that was my query. The
Oh,
I got like what you conveyed.
okay. Clear now?
Yeah, clear, clear, clear.
Okay, okay then. Well, good. Everyone is clear with these EOP operations, the 5 EOPs? Clear, guys?
Clear.
Everyone?
Yes, yes, yes.
Okay, now see, these are the ABCD of network, okay? But keep and hold on to this. These will build your foundations. Okay? Basics को कभी नहीं छोड़ना है. Never leave your basics. Fine. So, okay, coming back to this. Now, see here, there's okay, so okay, so we are clear with the life of the packet also, and now let's move further. Some more small basics. That is, whenever you will bring up your firewall for the first time, okay, that is unbox your FortiGate firewall, or sorry, your Palo Alto firewall. In that case, you will see that if in case you want to take access of your Palo Alto firewall, it will be the default IP is 192.168.1.1. Okay, that is going to be the case. That's the IP what you have to use in order to take your firewall access. Okay, the username and password is going to be admin, and I think everyone at this point would have got their lab access. Is there anyone here who has not got the lab access yet? Oh yeah.
Yes,
I haven't
Uh,
got.
I am.
I have not. I got the access, but I did not access. Sorry.
That's fine. That's your fault. Okay, but it's like everyone has got the email from the support.
Haven't got. I will check.
Yeah, please do. And sometimes the email lands into the spam folder, so please do check onto that also. And if still you have not received it, please follow up on your coordinator. And if they are not responding to you, let me know by tomorrow. I will follow up. Okay, fine.
Ron, inside it, when I go into this URL, I find this Rohan Palo Lab. That's the one where we need to
Yes,
go,
correct.
right?
That's my lab.
Okay,
Easy
okay,
peasy lab.
okay,
Yes.
okay.
Okay. Now, okay. See here. The next thing is something about the data plane and management plane. Okay, so the Palo Alto is distributed, the CPU is distributed in two planes, that is MGMT plane and the data plane. To put it simply, the management plane is responsible to handle all the administrative tasks. Like for example, you want to telnet, SSH, take GUI access, try to ping the firewall, right? So all these things will come into that play. The authentication related functions, the formation of VPNs, right? The IPsec VPNs and all that. The BGP, OSPF neighborships, maintainability, loggings, right? Loggings, reportings, and all that. All these things are handled by your MGMT plane. Okay, these are the main functions what your management plane handles. Okay, so let me write that down again. Your management plane is supposed to handle the management related activities like HTTP, HTTPS access, your SSH, telnet, okay, ping, all those kinds of things. Okay, management related functions. It is also supposed to handle or maintain your OSPF and BGP neighborship, your IPsec VPN related functions, your logging. Okay, so loggings and all that is maintained by them. Okay, so and yes, authentications also. So these are the main functions which is maintained by your management plane. Okay, whereas the data plane, whatever is left is maintained by data plane. To put it simply, it is supposed to handle or manage the traffic flow. Okay, like natting, UTM features like checking for viruses, your malwares, attacks, right? Doing the route lookup. Okay, so all these things will be handled by the data plane. And
So,
this is why, even if there is 100% CPU usage, okay, you will still see that the firewall has not stopped dropping your traffic. It's like no matter how the CPU usage is of the management planes and all right. So no one impacts the other. So even if there is a high or max to the CPU memory usage, I will still be able to access the firewall, make the configuration changes and all that. Why? Because those config changes, those accessibility is handled by the management plane. That's why. Okay, so they are interdependent upon each other. Okay, so that's where the flexibility come into play. So if you are running some sort of captures and all that, it will have not an adverse effect onto the firewall processing as such. unless you have impacted the data plane itself. So whenever you are running a process or a capture or something which is related to the data plane functioning, there you have to be careful, because if you spike that, then there will be an impact of the traffic. Else you do not need to worry. Okay. So
Sir,
what
this is
is that?
already
Sorry?
so this is only feature in Palo-Alto or other vendors are also there.
No, every firewall has some or less same thing. Everyone. Now everyone has it. Okay, it's not only the fire, almost like Palo Alto is specific thing.
Load balancing also managed by the management plan, huh?
Sorry?
Load balancing also takes part in the management plan.
Yes, load balancing is also part of the management plan.
Okay.
Yes, load balancing is also. It will be part of the management plane only. The HA activity is part of the management plane only.
Okay.
Okay.
ठीक है
Okay. Okay, fine. Now see, I think when we tried to brought up the lab there, I showed you how to configure the management interfaces and all, right? So if you will go into the, I was doing something there. Okay. So this is the management interface using the command line, what we configured. This was the exact same thing. If in case you want to do it with reference to GUI modification in order to define what and how or which all services will be working onto it, you can enable it from here, right? So you can assign the IPs and all that. You can also define that who all can access this firewall. So if you add the IPs here, permitted IP addresses, then it will only allow the access of the Palo from those added IPs. Okay, so if someone is who is not part of this added IP list, then he will not be allowed to access the firewall. Okay, so that's the control what you can get in here. But
Sir, I have one doubt. Hold on,
yes,
please.
please, yes, please tell me.
So you are talking about added IP. So for example, if you add so 192.168.1.5,
Mhm.
this IP is accessible, or this IP is assigned to some. This IP is, for example, my PC is going to access to this Palo Alto, sir. I am asking, sir. I have doubt on this.
Okay, okay, let's do this. Okay, let's say I'm saying 192.168 1.20. Okay,
Hmm.
permitted IP address is this. And let's say I'm also adding, well, okay, let's keep it in single wave only and press OK. Let's do that. Commit, commit it. Do, 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 do. No, 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 no. Okay, there you go. So I permitted it with reference to 1.20. Refresh it. See my IP here. Ideally, it should not have given me the access. IP config. अरे कहाँ type हो रहा है यार? IP config. Data. Okay. So my IP is 192.168.1.10. Let me log out. Oh, finally it kicked me out. Okay. See, I'm not able to access, right? Right. If I'm trying to access anything, it is not working for me. If I try to take party access also with reference to 192.168, 1.1, it does not work for me. Why? Because my IP is 1.10. The allowed one is 1.20. So let's change it. Now it is 1.20. Let's refresh. Here also let's take party. 192.168, 1.1. There you go. Access working.
Okay.
Rohan, we can define subnet as well,
Yes, you
like
can define
single
the
IP.
subnet as well. Since I have not defined any /24 kind of a thing, so that's why it took only that as specific single IP. Okay, but if you want to define the network, you will say 1.0/24.
Okay, we got it, sir. Actually,
Okay.
we need to change end of device IP address.
Sorry?
So end device IP we need to add in that particular.
Correct. Now,
Correct.
this is
So,
very useful. This is very, very useful.
so Rohan, in real life scenario,
Mhm.
what is the what is the use of this? Like, what is the use case for this thing? This
Okay,
this
I will give you the
feature.
same example what I have given this about the same feature in FortiGate also. And let me be honest here. The use case is, let's say you join, let's say I am part of a company called XYZ, okay?
Mm,
So there I was the senior engineer. So I had the super admin account access like this, the admin account access. Okay. Now
okay.
what happened is I left the company. Now I am part of some different company. Now, in my new job roles and all, what is happening is I'm stuck at some configurable deployment, and now I am thinking that in my previous company, na, I had done similar kind of setup. So I want to take a hint. Okay. Now presume I know that what is the domain on which my firewall is hosted for the outside access. Let's say, okay, because I was part of that company, right? So I can access that domain and try to log in as a super admin account. Now keep in mind, when I leave the company, when someone joins or someone leaves the company, the super admin account does not keep on changing every time someone joins or leaves the team, right? Your own personal account will be changed, but not the common super admin account. So this question, example, what I'm giving you is in terms of super admin account. Okay. So now I can log in, I can see what I want to see. I have logged it out. So I have not, my intention was not to harm you, but think in terms of XYZ company. There was a major breach that someone outside your organization was able to log in into your firewall because he knew about your logins, right?
Right.
So to prevent such a thing, it's like especially for the accounts, the admin accounts, which you do not or which does not change frequently by someone joining or leaving the team. That is constant. So for such accounts, you should apply this specific option that, hey, don't allow the users to access if they are not part of this subnet. That is your internal LAN. Okay. Now, to put it in a second way, I have I have given this example in the 48 also. Few years back, now during the COVID time, the AIMS database of Delhi was compromised, right? And the entire database of the patients were stolen and was sent or was being sold onto the black internet market and all. Okay. The worst part that when the people were selling that database, then when the agencies of India was aware that the AIMS database has been hacked. Okay. So no one had a clue that since how long the database was being hacked. When the RCA was done, the root cause was found because one of contractual employee who was having the access of the firewall deployed in that AIMS structure, he had saved the username password on his browser. And on his browser, he was having an extension add-on installed, which had a vulnerability which allows the hackers to access the password manager of the Chrome browser. See the luck. So the hacker hacked that user based upon that extension, the add-on what was installed into the Chrome, and he retrieved all his username and password. And in that list, one of that was AIMS firewall. And because of that, he was able to log in and move into it. Okay, so God knows how long he has been doing it, but that's the cause. Now, who is at the fault here? Maybe user, yes, he's not properly educated to how to handle the corporate IDs, the assets and all that. Yes, the lack of IT skill is there, but the lack of configuration, administrative manageability is also there. If the administrator would have taken a proper measures to control, not only based upon the username and password, but also apply the 2FA, also restrict based upon the IP accessibility, then it would have been a next to impossible job. Even if someone knows what is my username and the password, right? Yes or no? Clear. So these things matters. That's where setting up or defining the administrative access of a firewall or of any device must be taken into a very, very serious account. If you think that setting up a username and password is sufficient or setting up 2FA is sufficient, then you are mistaken. I have seen cases where the emails has been hacked and your 2FA is of no use, because two-factor authentication was sending the token to the email, and the person who was sitting behind, he was seeing what the token was coming. Okay, that the text has been hacked. So if you are receiving the token on your phone as a text message, that's where you are compromised, right? So that's why you will see that people often use Microsoft Authenticator, Okta Authenticator, right? Where you every 30 seconds there is a new passcode. Correct? These things are into play. Those days are gone of OTP and all that. Okay? So everything counts. And this is one of the feature which is a very simple but a very, very effective one. Because think, if I say that the people who are part of the private network, 192.168.1.0, see, it's a private IP. Meaning, if someone has to access your firewall, he must be within your LAN, because he can't be sending the request from his private IP to you sitting outside the network, because whenever that will happen, his IP will be netted to the public IP, right? That's how he can reach you, na? And the other way to reach is through the VPN connection. So how he can form the VPN link? Because if you think that if I use the address 192.168.1.0, then how I will access the firewall from my home? The answer is simple. Form the VPN link and then access the firewall, right? You can do it because you are the genuine user. So you can form the VPN, but what about the outsides? They can't. Right? So a single thing has saved you from a lot of efforts, right? Okay, so these are the use cases. I hope this answers your question. Okay.
Yes.
Fine. So that's for the day. Tomorrow we will learn about the types of interfaces. We will see the configuration use of that, what are the features that is applicable into the interface configurations, each and everything, and how to use it, where to configure it. Okay, so these are the things which we'll be talking tomorrow.
Rohan, before concluding, can you just share that notepad? I just want to take a screenshot of those 5 rules.
Oh, 5.5 rules. Okay.
Yep. Basics, but still very handy, you know.
Okay. Sorry for my English, but if there is something wrong, that
It
just
doesn't
makes
matter.
sense.
It's fine. Yeah,
Okay.
perfect.
And I see that no one has shared me the WhatsApp chat group link. No one has created it yet.
Oh,
Okay. If no one has done it yet, please do it tomorrow when the class starts. Please share that so that everyone can join, whoever is interested to be part of that group. Okay. Fine then. So let's catch up tomorrow. Tomorrow we will be learning the types of interfaces and where and how to use that.
sure. Thank you.
Thank you. Good night.
Thank you. Good night, sir.